We are going to solve this problem, which is like median of two sorted arrays. So there are like two sorted arrays were given, array 1 and array 2, and you need to find the median. So let's suppose for the simpler example, array 1 is like this, 1 comma 3, and array 2 is like this. Okay, so what would be the median in two sorted arrays? You need to combine those 1 comma 2 comma 3 and sort those arrays basically, and you need to find the middle element. You need to return the middle element. So answer is 2 in this case, and if the 1 comma 3 and array 2 would be 2 comma 4, then what would be the case here after sorting and merging those arrays? 1 2 3 4, right? So in this case there are like two middle elements, so the answer would be 2 plus 3. We are gonna get all those two middle elements and divide by 2, so it would be like 2.5. This should be the answer. Okay, so the question is clear, right? Hope the question is clear. So for that, what will be the time complexity? So this is the m length, n length. So first of all, you need to put m plus n, right? And then you are gonna perform the sorting operation. So this should be the this will be the length of the new array, right? Whatever you will be creating, like array 3 or something, this should be the length of the array 3, and log m plus n, this should be the time complexity of the algorithm by brute force, but after sorting. But we don't want this. We want optimal solution. We want to finish this in just log m plus n. Okay, so how we can do that? So we can do this using the binary search algorithm. So just for reference, I took the larger array so we can understand better. So let's just remove these all and let's focus on this. Let me put the elements here, like indexes 0 1 2 3 4 5 6 7 8 9 10 11. 0 1 2 3 4 5 6. Okay, so now you know there are like 12 elements here and 7 elements here. So you basically you got the idea. If the odd number, if we get the odd number after adding the length of these two, array 1 and array 2, we get the odd number, we will easily calculate the median. But if the even number is there, like after calculating, if suppose like let's say there are 8 elements in this and the 20, so we are gonna get two mid elements, right? So we need to calculate here for 2 mid and divide by 2, then we will get our answer. Okay, so no matter what the case is, we will gonna solve it. So let's see like what will be the optimal approach. So now you want the middle element. So what is the basics you need to know? So now you know total numbers after merging the total length will be 12 plus 7 would be 19, right? Now this you know, right? What is the median? So there will be like 5 here, 5 here if there are like 11 elements, and then this should be like middle one, and this should be our median, right? So we are gonna divide divide the entire array in two parts, and this would be our median. So if there is like odd number like 19, so there will be like 9 elements here, 9 elements here, and 1 element here, and this will be our median. Okay, right? 9 2 is 18 and plus 1 19. So we are gonna split this array in two portions. Like first portion will contain 9 elements, another portion will contain 9 elements. But this is when we merge this array. But we are not going to merge and sort, because if we merge this array, then we are gonna need to sort this. So how can we do that? So at least we now we know like what will be the partition, what will be the length of the partition. According to this you can calculate the length of the partition, right? If it is 19, divide by 2, simple. 19 divided by 2, it would be 9.5, right? Take an integer, so this should be 9, this should be 9, and 1 will be here. Okay, right? If let's say like 12 plus 8 is equal to 20, let's say like we have like 20 elements to all together, then what would be the partition? 10, 10, the last element of this and first element of this. We are gonna calculate using and calculate the median using these two numbers, right? So let's see. For current example, let's focus on 9, 9. Okay, as we got 19 is the total number. So let's say half will be total length divided by 2. Okay, this will give 9. Fine. Now if you are clear about this, hope you understand this. Now we are going to partition these elements. So first of all we are gonna perform binary search. Okay, but we are gonna perform on a smaller array. So we are gonna consider this array. Okay, so let's see. We need 9 elements minimum. Okay, 9 elements. If we take 5, let's say like I say I will take just 4 elements from this array 2, but we need 9 elements in one partition. So if we take 4 elements from this array, how many elements we are gonna need to take from array 1? 9 minus 4, right? So 5 elements we need to take from the array 1, right? This is the basic calculation. If we are partitioning in here, like if we are gonna take 4 elements from the array 2, then obviously we are gonna need 5 elements from array 1 just to make our partition as 9, right? You got this? Okay, cool. So let's see. So for the binary search we are gonna L left and right. We are gonna putting left and right here, and we are just finding the mid. Okay, so mid would be here, this would be mid, array 2 mid. Okay, so for the first iteration this is our partition, this is the part of our first partition. Now there are 4 elements, right? So we are gonna take 5 elements, as simple as that, from this array. Okay, now what? So we are just assuming we got this one partition. These are the elements which are gonna go inside the first partition, but is the partition is correct? That is the second question, right? So how we are gonna check if the partition we selected is correct or not? So for that we are gonna need these 4 numbers, this one, this one, this one, this one. Okay, so let's see what is the criteria. These all are sorted arrays, right? This is sorted, this is sorted. So what we need to check is this 6 should be less than or equal to the rightmost element of the partition in the array 2. Okay, this should be the this should be less than or equal to element at 4. Okay, at index 4, and this should be the less than element of index 6, element at index 5, sorry. Yeah, right. So we will just give a name as, let's put it here like A and B. Okay, this should be like a more easier task. This is array A and this is array B. So 6 would be, this would be A left, this is A right, and we are gonna call this as B left and B right. Okay, what is the condition? Now just focus on the condition. Let's suppose we found the partitions like 4 and 5, okay, is equal to 9. So we found the partition of 9 elements. Now how we are gonna check if the partition that we found is correct or not? So the partition we are going to check is B left should be less than or equal to A right, and not or, this is and A left should be less than or equal to B right. If this condition matches, then we know we are in the correct partition. Why we are saying this? You need to understand this as well, because as we are doing the partitions, we are just keeping all smaller elements on the left partition, right? We just want smaller elements. So this part and this part, so let's see, let me just tell you, let me remove this. Let me remove this as well. Okay, so let's say if I take these elements, let's these are like 6 elements I took, and these are like 3 elements I took, right? We are gonna fix our partition. We are gonna randomly check from here, not randomly, we are gonna do binary search for checking the partitions, and we are calculating remaining length from here. Like we got like six elements from here. Of course we are gonna just find like 3 elements from there, right? And initial elements, because they are like smallest one in the A array. Okay, right. Now what we are going to check, this should be the element at index 5 in B should be less than element at index 3 in A. Is this less than 5? 7 is less than 5? No. So this is not the correct partition. This is not the partition that we are looking. Okay, so that's the case. So let's see, this is the condition. That's why we need to satisfy this condition first. So once we get this condition, then we can figure out our answers so easily and so quickly. Okay, what else? What if, like for the current scenario, like I said, we took the 6 elements from here and 3 elements from here. This should be if, right? This is the if. What if it doesn't match? Elif. If the B left, this is the B left, right? If B left is greater than A right, right? If B left, this is B left, is greater than A right, so 7 is greater than 5, then what we should do? We are gonna shift our right pointer to the mid -1. So right would be mid -1. Basically we are just cutting this window. Okay, we are gonna shift right pointer to here basically. Okay, this is the logic, but we will come to that later on. You don't need to understand this like so quickly right now, we have so much time. Okay, we will just finish our whole logic and code quickly. So first of all, so let's revise once. So what you got to know, So first we are gonna check the total length, like length of A plus length of B, which is 19. Okay, cool. What will be the half? Okay, this will be the 9. If it's odd number or even number, we will figure that out later. So let's say for now it is the odd number, right? So there will be 9 elements here, 9 elements here, and 10th would be our answer. Okay, so you got to know this. So let's code for this. And also we need to fix like in which variable you are gonna put the smallest array, because you need to search by you need to perform binary search on the smallest array. Okay, you can perform on the largest array, but the code will change accordingly. So I'm gonna perform binary search on the smallest array. So let's see. So what we are going to do is, let's say this is the function. Let's write here, let's write our code here. Okay, def median to sorted arrays num1 comma num2. Okay, and we are gonna put a comma b is equal to num1 comma num2. Okay, if length of b is less than length of a, what we are gonna do, we want num2, we want b array should be with the smaller length. So then if, sorry, not here, if length of I was right, length of length of a is smaller than length of b. Okay, sorry for my mistake. So if array a has less element, then what we are gonna do, we are just gonna swap those. Okay, so now we know we have less elements in b array. Okay, cool. So this is you got. Now you need to find total length would be length of a plus length of b. Okay, you're also gonna calculate the half would be total length divided by 2. Okay, that's fine. Now you got the total length half. So this is the partition size basically, right? Partition size. Now you are gonna perform binary search on which array? B array, right? Correct. So for that you need like left pointer and right pointer. So let's initialize left comma right would be like 0 comma length of b minus 1. Correct. Now we are gonna put one loop while true. Why we are going to put infinite loop? Because somehow we are gonna return the element, right? At some point we are gonna return. And one more case I forgot to tell you is, what if our left, we can go out of index from here and here, right? With the binary search we are not putting like L is less than equal to right. So there might be possibility that left can go before 0. So what we are gonna do is, left won't go before 0, but yeah, right. So for that condition, while comparing, like we are comparing like A right, A right and B right. So window plus 1, this would be window plus 1. Okay, anyways, we will figure that out later. Let me just focus on the here. So mid of B, because like we are performing binary search on the B array. What would be the mid of B? L plus R, yeah, right, divided by 2, right? Simple. Now what we got? Now we got the mid. Okay, this is left, this is right, and this is mid. Oh, what did I put here? Mid B. Okay, let me put it as mid B. So basically, after putting the mid, what we are thinking is we are just focusing, like we are considering this is a part of our first partition, one part of our first partition, okay, which has four elements. So partition size is 9, right? How many elements we want from the second array? We needed elements. 9 minus 4, 5 elements we are gonna need. Okay, so these many elements we are gonna need, right? So we need like this index 5. If we need 5 elements, we are like simply gonna put like 5 minus 1 till index 4. We need all the elements till index 4. We need all the elements. That would be like 5 elements, right? Simple. So, and this would be mid of, we are gonna say here, okay, let's say mid A. This is not a mid A, but we are just gonna, I am referring mid A. Like you can suggest any name. This is not actually, we are not performing any binary search in A. I'm just giving a name as a mid A. Okay, so what will be the calculation for mid A? Mid A will be, what is the position size? So position size we have given like half. So here what we have calculated, half minus what, 4. So what is the 4? They're the elements, but the index is 3 only. So what we are going to do is we are gonna get here mid B, value of mid B plus 1, because mid B value is 3, right? Mid B is basically 3. The B of mid B is 5, right? So mid B plus 1 minus 1. Why? Because this is the 9 minus 4 minus 1. This will give the index of mid A, right? Will be 4. Okay, we got the 4, right? So this is the basic logic, and you will understand like once you watch this video again, or maybe like if you pay attention, like you will know. Okay, so let's put it on in the code. So mid A will be what would be half minus mid B mid b plus 1 minus 1, or else after solving this equation you can just also put it like half minus mid b minus 2, because minus 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 1 minus 1 minus 1 minus 2. So that's how like you can put like this as well, but I didn't understood this in the first go, that's why I simplified the equation and explained it, so you can get the better idea. So okay, now what, we got the mid a and mid b. Okay, cool. So we got the mid a here and mid b here. So now we are gonna calculate these four elements like we discussed. This one, a left, a right, b left, b right. Okay, again a left, a right, b left, b right. Okay, so let's say a left is equal to a right is equal to b left is equal to b right is equal to. Okay, cool. So what is the a left? It's nothing but mid a, right? The element at mid a. So a left is a of mid a. Okay, cool. A right is a of mid a plus 1. Simple. B left is b of mid b, and here b of mid b plus 1. Okay, cool. But also we are gonna keep the we are gonna consider the edge cases. So what we are gonna say, if it is like left side, so if mid a is just an index, right? So mid a is greater than equal to 0, then return a of mid a, else minus infinity. Minus 1 is 7. 1 is 7 is nothing but infinity. Okay, so 1 raised to 7, 1, so on 1 there will be like 7 zeros, that will be like minus infinity in the programming language. So you can do like float infinity, float minus infinity as well, but instead of this, like I do like this. Same, if mid a plus 1, here we are calculating mid a plus 1, is this is the right side, right? So if this is the less than length of a, why? Because this should be less than length of a, right? Else it would be the positive infinity. Same we are gonna do is with b. Mid b is this the left side, so this should be greater than or equal to 0, or else minus infinity. If mid b plus 1 is should be less than length of b, else it would be like positive infinity. Okay, I just hope these are clear. This is the left, so this should be greater than or equal to 0, right? This is the left index, so left index should be greater than or equal to 0, otherwise it will be minus infinity. The right should be less than length of a, otherwise it would be plus infinity. Same goes for b. Okay, now if you understood the code till here, then it's almost got sorted out. Now we are going into the main part, the condition. Now we got the partition. Now we got the partition in both. So A left, A right, B left, B right. Okay, and we are gonna do cross checking. We are gonna check this and we are gonna check this. Okay, so let's write code for that. So if what we need, if A of sorry, we already took the index, right? So A left, sorry, A left should be less than or equal to B right, and B left should be less than or equal to A right. Okay, if we get this, then what did we say? We are in the correct partition. Otherwise, what would be the case? If maybe this might possible that this element is not less than this. So basically this is 8 and this is 7, which is the wrong thing, right? So at this time what we need to do, we need to shrink this window, and according to, if we shrink this window will get automatically increase, right? That's our code. That's how we are calculating window of A later. So we are just determining the window of B, and according to that the window of A will get calculated. So what we are gonna check is B left. Okay, what is here? B left, elif B left is greater than A right. Okay, B left is greater than A right. Then what should we do? We are gonna shrink the window. So our right pointer will be mid -1. Else what we are gonna do? Our left pointer will be mid +1. Same as it is, right? Now all code is done. We just need to figure out what we should do in this current partition. I'm just hoping you understood whole code except this. Okay, we are going to go in the correct partition code. So let's revise one more time. We are putting all the windows nums1 and nums2 A and B. If the length of A is less than length of B, we are just gonna shuffle, because we want less elements in B array. Okay, B list, we call array as a list in Python. So let's see. So total length would be length A plus length B. Okay, done. Half would be total length divided by 2. Okay, done. So we are gonna, this is for binary search. Okay, so we are initializing the left and right pointer. We are performing binary search on B array, so that's why like we took the B index. Okay, length of B -1. Okay, pointers are set. While true, we are just keep performing the loops, and we are just performing binary search again and again till we get the right window. Okay, cool. So let's see. So first here, like we calculated the mid, this should be the window in the B, and according to this we are calculating the window in A. Okay, the calculation is simple calculation. I explained the calculation here. You can go to the previous part of the video and you can check this calculation out, how we decided the length of the window of A. So we need these four elements, these four variables, these four numbers basically. And if it is like left side, this should be mid A is basically index, mid B is also index. So if the index is on, we are looking for like left side index, that's why left side index should be greater than or equal to 0, right? Otherwise we are just putting minus infinity. And if it is like right side of index, then the right side index should be less than length of array, and otherwise we are putting the positive infinity. Okay, and here we are just checking, this is the condition for the correct partition. We are doing the cross checking here. A left should be less than B right, and B left should be less than A right. Okay, so basically this should be less than this and this should be less than this. Okay, cool. If we get that window, then we are in the correct partition. Okay, cool. What else? If B left is, suppose let's say this is greater, if B left is greater than A right, so this is like 2, let's say. So in our window, this is not like we store the minimum in the first window, right? First partition. So 2 is minimum than minimum in 2 and 7. So our window is wrong basically. So we are gonna shift this window. So that's why we updated the pointer r is equal to mid minus 1. Otherwise this is nothing but if this is basically B right is smaller than A left. This is the same for L, but this will take care automatically with the L. But I'm just saying like this should be the condition. Then we are gonna shift the L pointer to the right. Okay, cool. Okay, so cool. So let's focus on the current partition then. If we get the correct partition, then what we should do? Let me put this below little. Okay, so now we got the correct partition now. So there are like two cases. Total length is odd, or even. We are gonna check for that, right? If we get the total length of okay, so let's code for that. If total length, what is our like variable name? Total length. Okay, cool. Modulo 2 equal to 0, then this is basically we got the even length. So what if it's the even length? We are gonna get two elements. So let's focus on like else part first of all. So return, we are just gonna return here, what we are gonna return? The minimum of A right and B right. Okay, so what will be the answer? So this is our first window, right? So this is the correct window we got in the first initial phase. Luckily, we can try out with the another example as well. We are just gonna check 6 is less than equal to this. Okay, condition satisfies. B left is less than equal to A right. Okay, cool. Let me just put here A left, A right, B left, B right. Okay, I'm just putting the values here. A left is 6, A right is 7, B left is 5, here 6. We are gonna check A left with B right and A right with B left. So the left element should be less than the right element. Okay, in here. So left element is less than right element. Okay, cool. Left element is less than or equal to right element. Yeah, cool. Condition satisfies. We got the required window. Okay, cool. Now comes to the picture. We got this window, right? Okay, we got 9 elements here. 4 elements from this, 5 elements from this. Total length is 19. This is the odd. So we are gonna give this should be the answer. So what will be this one? This element will be the minimum of this and this, right? So what is the minimum? 6. So that's why we are gonna return minimum of A right, comma B right. Okay, understood? Again, we got these windows combined is this window, right? Answer is here. The next element after this window. What will be the next element after this window? The minimum of this and this, right? What is the minimum? 6 or 7? 6, of course. So answer would be 6 in this case. Okay, cool. And what if we got the same partition? Okay, we will also consider that. There are like 5 elements, total 10 elements. Here 5, here 5. Okay, then what would be the case? Then we are going to check, this is the window, we are going to check what is the maximum of this one and this one and minimum of this one and this one, right? Because we got this window, right? We just want to find the last element. So for this window, what would be the last element? The maximum element, then in these two, right? So else return, let me put the bracket, maximum element of A left, comma B left, plus minimum element of, why I'm saying minimum element? Because we are gonna need 2 elements, right? And we are gonna find out the next element. What would be the next element? This or this, right? So we are gonna find the minimum, which will be second element. So let me put it here, like minimum element of A right, comma B right. Okay, bracket divided by 2. We are not putting like 2 because we can return the answer in float. Okay, finally that's the whole code, and that's the whole code for returning the median of 2 sorted arrays. It is simple if you understand it slowly. The only concept which took my time was this one, but if you understand this, it is so much easy and you can write on your own. Okay then, thank you so much.